All right, here we go. We're going to calculate titrations. So yes, you can calculate titrations. So let's talk about it real quickly. Titrations. All right, what is a titration? You should have watched the other videos, and hopefully you learned that a titration is when either you have an acid or a base that you do not know the concentration of. Okay, you know what it is, so you know it's like hydrochloric acid or sodium hydroxide, but you don't know the concentration of it. Well, you can figure out the concentration doing a titration. All right, dropping one drop at a time. If it's an acid that you're trying to find out the unknown, you drop a base into it. And you can use a pH scale or a pH meter, or you can use an indicator. All right, you probably want to use both. And when you do that, well, you get a lovely graph that comes out of it. So I'm going to show you a couple. All right. So this could be a graph that comes out of it when you're trying to do a titration. And what you see here is we have an unknown acid. Okay, we have an unknown acid, and what we're adding is a base to it. Okay, so we have an unknown acid, we're adding a base to it. So this is the volume of your base. So you're adding drop by drop. Now, pretend we have a pH scale in our beaker. So, and we're graphing it. So as we keep on adding base to it, hopefully that pH is going up, right? Because bases pH are from 8 to 14. So our pH is increasing. So we're starting to neutralize this. Well, what you'll see in your graph is it goes up slightly and all of a sudden, boom, it shoots up. Right? At the highest slope here, so as we go up as our highest slope, which will be here, that is known as our equivalency point, or our equivalence point, okay? So that's the equivalence point. And what we do there is we're going to stop there, okay? Well, we can graph the whole thing, but this is the, when I say stop, that's the important point we should use, okay? When we do our calculations that I'll show you in just a second. So this is the equivalency point. Now, when doing a titration, the equivalence point does not have to be at a pH of 7. Let's look at a second graph here. So once again, this is the volume of an alkali. They're adding a base once again to an acid. So as you can see, it's kind of flat. pH is kind of going up, and all of a sudden it shoots up. All right, so our equivalency point looks like it's right there. When I look over, look, it's higher than a pH of 7 here. All right, it looks like it's 9.2 or something. Okay, so on this titration, our equivalency point is not equal to a pH of 7. That's okay. All right, the important part in titration is knowing where your equivalency point is. All right, so what we're going to do now is show you how to calculate a titration. All right. So, to calculate a titration, there's an equation for it. All right? Basically, here's what this equation means. So I'm going to show you what it means first. We want to know that the moles of the hydrogen ions, or you can put hydronium ions, however, so our acid is equal to the moles of our hydroxide ion, or our base. So that's our goal. They need to be equal to each other. So our equation works like this. You have molarity, volume, times N equals molarity and volume times N. What do these mean? Well, we just said this is molarity. We've calculated that for. This is going to be for our acid. So the molarity of our acid. This is going to be the volume of our acid. And the N right here is going to be the number of hydrogen ions. This side here, molarity, this is still molarity, but this time it's of the base, volume of the base, and then our N here is going to be the number of hydroxide ions. Okay, so MVN equals MVN. Might be a little easier if I show a problem. So here we go. Alright, let me get my sheet here. Here's our problem. If 42.5 milliliters of a 1.3 molar potassium hydroxide solution is used to neutralize 50.0 milliliters of H2SO4 sulfuric acid. What is the molarity of H2SO4? So what's the molarity of our H2SO4, our acid? All right, first thing you have to do, you have to have a balanced equation. So we have H2SO4 plus KOH. Neutralization reaction, what do we know it makes? Salt and water. So potassium is just K plus, SO4 is 2 negative, so this is going to be K2 SO4 plus, well, our waters need to be made, so H2O. Alright, so with all that being said, we got to balance this, so I know I'm going to need a 2 right there, and we're going to need a 2 right over there. And I'm going to be balancing quickly. If you need some help with balancing, please come in for extra help. Alright, let's make sure these balanced. So 2, 4, 4, sulfate, sulfate. They look good. Alright, so let's plug into our equation. Alright, remember our acid was on this side. So we don't know the molarity of H2SO4. So we do not know our molarity of our acid. Do we know the volume? Well, we do. They told us the volume was 50.0 milliliters. So molarity times 50.0 milliliters times the number of hydrogens. We need to look into our lovely equation here. It tells us our number of hydrogens is 2. So we have 2 hydrogens that are going to come off of sulfuric acid. Is equal to, now the molarity of the base they did give us. We look back up here. Molarity is 1.3 molar times our volume is 42.5 milliliters. All right, times our number of hydroxides, KOH, 1 hydroxide. All right, with all that being said, we're going to manipulate our equation. We know molarity is going to be equal to 1.3 molar times 42.5 milliliters times 1 divided by, we're going to take these over, 50.0 milliliters times 2. Alright, hopefully you see here, your milliliters are going to cancel. We're going to be left with molarity. That's a good thing. Let me get a calculator to plug this in. So we got 1.3 times 42.5 times 1 divided by 50 times 2. Alright, and our molarity of, we were trying to find the molarity of our acid. So our molarity of our acid is, with 2 sig figs, 0.55 molar. And this is how you do a titration calculation. Alright, we'll do some more in class, so hopefully you're watching this, and hopefully you understood. If you don't, please come with questions tomorrow. Alright.